Okay, so let's have a look. Okay, so your formula, you're going to say percentage of calcium carbonate. You're going to say percentage of calcium carbonate. Calcium carbonate. Right, it's going to be equal to, it's going to be mass of calcium carbonate, mass of calcium carbonate divided by the mass of the antacid tablet. 3.2 is the one that we did after before break that you said I must show you the formula. Then mass of antacid tablet. Antacid tablet. Right, multiply by 100 over 1. Then we're going to substitute, which is going to be 0.1 over 0.25 multiplied by 100 over 1. Then your answer becomes 40%. So that's what you get. That's how you get your answer. Mass of calcium carbonate over the mass of the antacid tablet multiplied by 100 over 1, which is 0.1, divided by 0.25 multiplied by 100 over 1. Then you get your answer to be 40%. Clear? Right. Okay. Yes. Yes. No, it's the one that we got from the graph. When we extrapolate on the graph or interpolate in the graph. It's the one that you are joining. Remember, there was a volume of gas that was produced. So we're using that 25. You join it to the graph and find the corresponding mass from the graph. We cannot use we cannot find number of moles here. Why? It's because we are not told that it is at STP. It's not STP. So we can't use number of moles equal to V over Vm to get the corresponding moles of calcium carbonate. Then we use those moles to determine the mass of calcium carbonate. We make use of the graph that is given. Right, are we done? No. Right. Okay, let's move on to the next one, the last one. All right, we need to move a bit faster so that I can finish up with this. All right, so let's look at the last question. The last question said, let me move this. All right, it says, calculate the volume of hydrochloric acid that will be neutralized by 1 antacid tablet for 5 marks. Calculate the volume of hydrochloric acid that will be neutralized by 1 antacid tablet. Right? How do we do this? What are we looking for? We're looking for volume of acid. What do we know about the acid? About the acid, we know its concentration is 0.1 mole per cubic decimeter. Are we together? All right. So let's work it out and see. All right. So I'm going to go back to my whiteboard. All right. Right, so we look at the reaction that we're given. What is the reaction that we're given? We're given calcium carbonate Calcium carbonate reacts. Calcium carbonate reacts with what? Reacts with the HCl, hydrochloric acid. We are given this equation here to give us calcium chloride. To give us calcium chloride plus what? Plus right, plus you've got your carbon dioxide plus water. Right, to balance this, you put a 2 here. So here you're going to have a 2. Right, 2 is for balancing. So if you check your calcium here, 1, calcium 1, carbon 1, carbon is 1. Your oxygen is 3, oxygen here is 2 plus 1, which is 3. Your hydrogen here, 2, your hydrogen here is 2. Your chloride is 2, your chloride here is 2, so it's balanced. Clear? What do we know? What are we required to find? We are given here hydrochloric acid. Hydrochloric acid. All right, what do we know about hydrochloric acid? We know the concentration. What is the concentration? Is 0.1 mole per cubic decimeter. I'll just write molarity, mole per cubic decimeter. What else do we need here? All right, what are we looking for? We are looking for the volume. So we need volume. We don't have the volume. Right, we know this equation goes together with the number of moles. So we need number of moles. We don't have number of moles. Are you following? All right, for us to get the volume, we have concentration, we don't have number of moles. We need to find this number of moles. How do we find this number of moles? We need to check what are we given. From calcium carbonate, calcium chloride, carbon dioxide, and water. What do we know? What are we given in this particular question? What are we given? If I can just go back to the question here. What is it that we are told here? Let me just put this. Right, what do we know? There's that information that we have here. Actually, this whole information that starts here, all the information that is here in this paragraph before questions are asked, all of this, it means it applies for all the questions that follow here. This. Right, so what do we know? We know the antacid, it's 0.25. But in this antacid here, we split this into 2. We have got major, the mainly part, and the minor part. The major part, that's your calcium carbonate. You've got your calcium carbonate. All right? And the minor part is those other additives that you're going to have here. You got your additives that are added into that tablet. Right. What else do we know? We know the concentration, 0.1 mole per cubic decimeter. What else do we know? We know that we have right. What else do we know? We know 25 cubic centimeters of carbon dioxide is formed when one antacid. So all of this is talking about one antacid tablet. 25 cubic centimeter of carbon dioxide is produced. When 25 cubic centimeter of carbon dioxide is produced, can we use this? Because this information is at our disposal. Can we use this to find the number of moles? Huh? Yeah, how are we gonna find the number of moles? What formula? Convert, then which formula? Number of moles is equal to V over Vm. All right, let's check. Do we have the volume? All right, we are looking for number of moles, isn't it? What are we going to use as Vm? Where is STP here in the question? Do you have STP here? No, so you cannot use that. So you cannot use 25 to find the number of moles for carbon dioxide. You can't. So this approach is not going to work. Why? Because it's not at STP. We don't know whether the temperature was 0 or not. It's not 0 basically if it's not said here. Is that understood? So this approach, it means we cannot use this. So we leave that one. We come to this. It says use the information on the graph. So using the graph, we can find the mass of calcium carbonate, which is what we did in question 1.3.2. What did we find to be the mass of calcium carbonate if 25 cubic centimeters produced? What do we know? We found that it was 0.1, isn't it? So we have the mass of calcium carbonate. So we're going to use mass of calcium carbonate to find the number of moles. After we find calcium carbonate, now we can find the number of moles for hydrochloric acid. If we find the number of moles of hydrochloric acid, now we can answer the question. That's why there are 5 marks. Why do we have 5 marks? Because we need to start by finding number of moles of calcium carbonate. Then that will help us to find the number of moles of hydrochloric acid. Good, let's do that. All right, let's go back to the, let me grab here, clear. All right, let's go to the page that I was sharing with you here. Right, so now from here, what do we know? We know calcium carbonate, we know the mass here. We know the mass, we know the mass. What is the mass? 0.1 grams. Right, the molar mass, we can find molar mass from the periodic table. What is the molar mass? Calcium is going to be 100. Calcium is going to be 40. Carbon is going to be 12. That's 52. Oxygen is 16 times 3, which is 48. 48 plus 52 gives you 100. You get 100 grams per mole. That's the molar mass. Right, we can find number of moles. So let's calculate number of moles. We are looking for number of moles of calcium carbonate. Yes.
But say they said here calculate the volume of hydrochloric acid. They didn't mention anything about calcium carbonate.
Yeah, but how many marks was it?
5.
5. 5 means how many formulas? It means 2. So the 2, the formula that we're going to use to calculate volumes is C, concentration. Which concentration is this? HCl. It's going to be concentration of HCl is equal to number of moles over volume. Do we have concentration here? Yes. Do we have number of moles here? No, we don't have this. Do we have volume? No.
But say here we're talking about hydrochloric acid.
Yes.
So why are we using calcium carbonate?
Because we know something about calcium carbonate that's going to help us to find the number of moles for hydrochloric acid.
But then how do they link?
How do they link? The balanced equation links them. They are linked by this balanced equation. The ratio here is 1:2. So if I know the number of moles of calcium carbonate, I can find the number of moles of hydrochloric acid by the ratio 1:2. That's the stoichiometry. You are working with what you have to find what you do not have. Are we together? Because we know they always react in 1:2. So if I have 5 here, then it means here to be 10. If I have 100 here, then I can find this one. That's the stoichiometry part. Yeah? Good. Yes. Which one? The 0.25. Which one? The 0.25. Or the 25. Okay, the 25 that we're given from one anti-acid tablet is this. It's this one that is coming from this. We know this. We know the volume is 25 here. It's not for everything, it's just for the carbon dioxide. So here we know the volume here is 25 cubic centimeter. If we knew that it was STP, we can also use carbon dioxide to find hydrochloric acid, because the ratio here also is going to be 1:2. So if we know this, we can use it to find HCl. Are you following? But why are we not taking this approach? Because it's not at STP. We don't know. We only have one variable here. We don't know VM. We don't know what is VM because the temperature is not standard. So we won't be able to get number of moles. Is that understood? So this approach does not work. We work with the one that is here. Clear? Right, so number of moles of calcium carbonate is going to be mass over molar mass, which is going to be equal to, the mass is 0,1 divided by 100. Right, is equal to, then your answer here becomes 0,001 moles. Right, these are number of moles of calcium carbonate. Remember, that's not what we want. We want this to help us to find number of moles of HCl. So what do? You go to your ratio, mole ratio. Where? Y3. Because it's 0,1 divided by 100. You just move your comma 2 places. Right. So you get your ratio, mole ratio. So you're going to say calcium carbonate is to HCl. Right, what is the ratio? The ratio is 1:3. 1:2, sorry, not 3. So it means if I've got 0,01 here, how much am I going to get here? I'm going to get double here, isn't it? And double here makes it how much? 0,02. Now I've got the number of moles of hydrochloric acid. Now I go to this equation here and I'm going to substitute. Concentration, what is the concentration? 0,1. Number of moles now I have, so I'm going to put 0,002. Divide by the volume. Whose volume is this? Volume of hydrochloric acid. Then I cross multiply. This is over 1. So I'm going to have V is equal to, these two swap. 0,1 comes here, V goes there. So I'm going to have 0,0002 divided by 0,1. What's your answer? Your answer becomes 0,000. No, it becomes 0,2. 0,02. Yeah. 0, this 2 moves that way. Okay. Right, so I'm going to get 0,02. Right, what is the unit? Units of volume? Cubic decimeters. That's my answer. That's the volume that we want. Right, let's check. How do you mark this? It's 5 marks. So you're going to get a mark for substituting here. 0,1 divided by 100. 1 mark for the ratio, finding the number of moles here, 0,002. 1 mark for formula. Concentration is equal to number of moles over volume. 1 mark for substituting. 1 mark for the final answer. Those are the 5 marks that you get. Those are the 5 marks that you get. All right. Okay. I'm going to have to move fast. I've got about how many minutes? 12 minutes left. All right. Quickly. I need to move on to the next one. The next one is your percentage yield. Percentage yield. Right, so we are done with this. Then we look at percentage yield, which brings us to the last part of your stoichiometric equations, your stoichiometric calculations. Sorry. Right. Can I proceed? Okay. Let's look at today's work. Right. So here I wrote theoretical yield, but the calculation that we're going to be involving is percentage yield. For us to find percentage yield, we would need your theoretical yield. So let's start. What is theoretical yield? When we are given a known mass of reactant and are asked to work out how much product is formed, we are working out the theoretical yield of the reaction. So what we've been doing, just working from a balanced equation, that's theoretical. Theory means what you do without actually doing the activity or without actually doing the exercise. For example, you are baking, you just check there, your ingredients need so much flour and so much, then you can just calculate how much am I going to get from the 1 kg that I have. Are we together? That's theoretical. Then when you actually do the baking, then you find the number of muffins that you have, that becomes your actual number. So let's say on the packet, I think you buy a 1 kg, they write 24. 24 is just maybe your theoretical according to the amount of flour that you need. But when you bake, you find that you get 22 muffins. 22 that you get when you actually bake, that's your actual yield. To yield means to get or to harvest, right? So your theoretical yield is what you get when you do in theory. Actual yield is the amount that you're going to get when you actually do the process, right? So for you to find percentage yield, what you're going to do, you're going to say the 22 that you got when you actually bake the muffins and the 24 that recipe says you're going to get. So 22 over 24 multiplied by 100, that gives you the percentage yield. So percentage yield must always be less than 100%. You hardly get 100%. Why? Because as I'm baking, I might spill the flour. As I'm baking in the Tupperware, there's maybe what is this? The flour that is going to be sticking on the bowl. So I lose some of the flour. Maybe when I was baking, I was distracted. Then in the oven, maybe 2 bent out. You follow, right? All of that counts on your percentage yield. Why is it important for us to know percentage yield? Because companies, when they do this, they are doing it for a profit. The lesser my percentage yield is, the loss I'm getting. So I need to try and minimize the loss. Are we together? All right. So percentage yield tells you whether you are profiting or you are losing. Right. So in the laboratory, chemists also never get this amount of product. In each step of a reaction, a small amount of product and reactant is lost, either because the reactant did not completely react or some other unwanted products are formed. This amount of product you actually got is what we call the actual yield. You can calculate the percentage yield using the following equation. So you're going to say actual yield divided by theoretical yield multiplied by 100. If you see that your answer is over 100, there's something wrong. Maybe you've swapped the two. Maybe put the theory on top and your actual at the bottom. Your answer must always be less than 100. Clear? Right. Then let's look at an example. Industrial reaction to produce fertilizer. What is a fertilizer? Right. Fertilizer is the nutrients that you give to the plants to make them grow faster and healthier. Right. So we have your sulfuric acid, H2SO4 reacts with ammonia, NH3, to produce a fertilizer called ammonium sulfate, written NH4, 2SO4. What is the theoretical yield of ammonium sulfate that can be obtained from 2 kg of sulfuric acid? It is found that 2,2 kg of fertilizer is formed. Calculate percentage yield. So here there are 2 questions. You need to find theoretical yield as well as percentage yield. First one, what do? Write the balanced equation. So here you're not given the equation. You have to make the equation from the statement that is given. So you're told sulfuric acid reacts with ammonia. Those are your reactants. To produce, that is your product. So that's what you're going to write. And make sure you balance it. Right. Number 2, calculate the number of moles of the given substance. What substance was given? What was given is 2 kg of sulfuric acid. So you have sulfuric acid. You need to find the number of moles. Number of moles is equal to mass over molar mass. Your mass was in kilograms. Standard units for mass in chemistry is grams. So you have to convert your 2 kg into grams by multiplying by 1000. Then you get 2000 grams. Divide by the molar mass of sulfuric acid. What is the molar mass of sulfuric acid? It's 98. It's going to be your 2 plus 32 plus 64. That gives you 98. 2000 divided by that, you get 20,38 moles. Next one, you go to the mole ratio. Mole ratio, remember, we need to find the product. So sulfuric acid is going to help us to find the number of moles of our product. What is the ratio here? It's 1:1. So the number of moles of sulfuric acid are the same as the number of moles of ammonium sulfate. So your ratio is 1:1. It means the number of moles that we got for sulfuric acid are going to be the same as the number of moles of ammonium sulfate. You move on to the next one. Right. We haven't answered the question. Now we have the number of moles. We need the mass of the product that we're going to get. So what we're going to say, mass is equal to number of moles times molar mass. We take that 20,38 that we got above, and the molar mass of the substance that we want to find, which is the product, which is ammonium sulfate, which is this. So you're going to have nitrogen, which is 14 times 2, 28, and you've got hydrogen, which is 1 times 4 times 2, which is 8, then plus sulfur, which is 32, then oxygen, which is 16 times 4, which is 64. Your total comes out to be 114. Then you multiply the 2, you get the mass that is produced of the fertilizer, which is 2,324,47 or 480 if you round off to 2 decimal places. Right, so your mass, this was rounded off to the nearest whole number, but please keep it 2 decimal places. Then this is the first part of the question. Now the second part, calculate percentage yield. Percentage yield, what do? Actual yield. Actual yield, when this was actually done in an experiment, how much was got? They got this. It is found that 2,2 kilograms of fertilizer is formed. So when this person did the actual making of the fertilizer, you got 2,2 kilograms. That becomes your actual yield. The one that we calculated, 2,34, that becomes our theoretical yield. So you took those two values and make sure the units are the same. If you keep it, use grams, the top one must be grams, the bottom one must be grams. If the top one is kilograms, the bottom one must also be kilograms. So you come here, you've got 2,2 kilograms over 2,324 kilograms. They're all kilograms. Multiply by 100 over 1. You multiply that, your percentage yield becomes 94.64%. So this is the percentage yield. So you're not getting 100%. The 5% is because of other losses that you incur as you are doing the actual experiment. Is that clear? Right. So there's exercise 37 for you, percentage yield. You guys, you need to do this. I put 4 questions for you to be calculating percentage yield. All right. So please just note, don't confuse the actual yield and the percentage yield. Right. So use that to do that activity. Any questions? Okay.
So,
Yes.
so can't you do another example there, sir?
Okay, my time is up. I would love to do another example, but my time is up. Just try it. If you have a
Okay, sir.
if you have a challenge, just send me a question on WhatsApp. Then I can always we can always chat on WhatsApp, Zinedine, and any other one who's got a problem.
Okay, sir.
Yes.
Sir, that's 2,324 there, sir.
Yes.
Why did they shift the chromosomes?
I know, isn't it? They wanted to match. Check here. This one was grams, isn't it? It was grams, but the 2,2 was The 2,2 was kilograms. So they have to change grams to kilograms by dividing by 1,000.
Oh, but oh, I know.
You
But
can
so
you can.
in science we use the.
It doesn't matter. Here, if you this is kilogram, they're gonna cancel. You must just make sure the units here cancel. You can't have grams.
2,2.
Yeah, you can change it to
grams.
To grams. Yes, you can do that. Yes. Must scroll down. Must scroll down. Okay. Yeah. Yeah, this is the actual. Yes, that's actual. Right. Hello, please. Yes. No, you must try. Why do you say that? Did I move too fast? Okay, because of time. My time is up actually. This lesson is supposed to end what time? 36 or 37? 34. There's 3 minutes for me to move out. Right, okay. Like I said, try and do it. If you've got a challenge, please ask me. Please ask. On WhatsApp. Or you can see me before you leave. Right. Huh? Yeah, there is a group, I think. Joshua created one.